All right, let's get right into it. If you've ever felt like you're just stuck, running through security checklists and drowning in noisy alerts, then you're in the right place. We're going to talk about moving beyond that into a much more intuitive way of finding web vulnerabilities. Basically, learning to recognize the shapes they leave behind.
And this, right here, just gets to the absolute heart of it, doesn't it? This isn't about some textbook theory. It's about the real-world, hard-won lessons from the field. It's about developing that gut feeling, the one you only get after seeing the same fundamental mistakes dressed up in different clothes year after year.
I mean, we've all been there. Your scanner lights up like a Christmas tree, you get that little jolt of adrenaline, and you think, this is it. And then, it's nothing. You spend the next hour just trying to prove that a so-called critical finding was just an echo in a debug log. It is so frustrating, and man, what a waste of time.
Yeah, and what's really interesting about this story from the source material is just how common it is. So the payload got reflected in the response, sure, but it never actually hit what we call a sink, a dangerous function like a database query or a command execution. It never did anything harmful. The tool just saw a scary-looking string, not a genuine risk. And this is the exact kind of ghost we need to stop chasing.
So this first section is all about that exact problem, that wild goose chase for ghosts in the machine, and what it really costs us.
And this is the part that really matters. When you keep flagging non-issues, you're not just wasting your own day. You're burning through social capital with the development team. They start to tune you out, their eyes glaze over, and then, when you finally find something that is a huge deal, it just gets lost in all that noise you've been making.
Okay, so if that's the problem, how do we fix it?
Well, it takes a bit of a mental shift. We need to move from just reacting to every little blip on the radar to proactively looking for familiar shapes, these recognizable patterns of failure.
This slide just captures the two approaches perfectly. You've got the sightseer on one side, who kind of just sprays payloads everywhere, hoping to get lucky, but the pattern spotter, they're methodical. They ask the important questions like, where is the boundary between trusted and untrusted data? How is this specific feature most likely to break? It's a much more focused, almost surgical approach that starts with what really matters: identity and data.
I love this quote because it's so blunt and so true. A trust boundary is just that line, where your application stops trusting input. It's as simple as that. And if you don't know where that line is for a given feature, any payload you send is just a shot in the dark. Naming that boundary is the very first step to real, effective testing.
Let's make this super practical. Right now, think of one API endpoint in an application you work on. Can you describe in just one sentence what data it trusts and what data it has to validate? Something like, the user profile endpoint trusts the session cookie for the user ID, but it validates all the other submitted form data. Simple, right? But incredibly powerful.
Okay, so with that new mindset, let's look at 3 specific, really high-impact patterns that just show up again and again and again in modern web apps.
Now, the source material maps out about 20 of these common patterns, but we can group them into these big categories. We're going to pull one example from identity, one from the input layer, and one from logic, just to show you what these look like out in the wild.
Our first pattern is an absolute classic. I mean, it's a true Hall of Famer in the world of web vulnerabilities, and it falls squarely in that identity and sessions bucket.
You've probably heard of this one, maybe as BOLA or IDOR. It's this simple but totally devastating flaw where the application checks if you're logged in, but it forgets to check if you're allowed to see the specific thing you're asking for. So you request invoice/123, you change it to invoice/124, and bam, suddenly you're looking at somebody else's private data.
And here's the modern twist where it gets really interesting. You might fix this on your main web application, but what about the API that serves your mobile app? In this story, the developers patched one endpoint, but a completely different route, the one used by the mobile client, had the exact same vulnerability. It's such a powerful reminder to test all the ways data can be accessed.
All right, let's look at our next shape. This one deals with input and execution, and it's a bit more subtle, a little more sneaky than our last example. So what is SSTI? Well, imagine a feature that lets you customize an email with your name. SSTI happens when the application isn't careful, and instead of just displaying your name, it actually executes your input as if it were part of the template's code. Think of it like this. It's the difference between the server showing hello 7 times 7 and showing hello 49. One is just text, the other is computation. This story just perfectly captures the danger.
A bug in a preview function was initially just brushed off as a simple user interface issue, but because the template was actually being rendered on the server, that little UI bug was a backdoor for running code. The lesson here is crucial. Never ever assume a bug is just UI until you know where the rendering is actually happening.
Okay, our third and final pattern steps away from syntax and weird input entirely. This one is all about breaking the application's intended purpose, its business logic. Honestly, these are some of my favorite bugs because they're not about clever payloads. They're about breaking the rules of the application. The app has an expected order of operations, right? You add to cart, then you check out, then you pay. A state machine break is when you find a way to skip a step, like jumping directly to the order complete page without actually paying. And this anecdote is just a crystal clear example of that. The developers just assumed that only the server could mark an order as completed, but it turned out that the status was just a hidden parameter being sent from the user's browser. So by simply changing that value, a user could bypass the entire payment process. This highlights a core rule of security. Never trust the client to enforce business logic. Okay, so we've seen the mindset and we've seen the patterns. In this last section, let's turn it all into a concrete workflow you can literally start using today.
See, this isn't about spending days and days testing. It's a focused, three-pass approach. First, you start with identity. Who can do what? Then you focus on the highest value targets, the most critical functions in the app. And finally, you validate the rules of the game, just like we talked about with the state machine breaks. It's a powerful routine, not some exhaustive checklist.
And that is the big takeaway here. Forget about memorizing hundreds of specific attack payloads. Instead, build a simple playbook that's focused on these high-level patterns. A consistent routine that looks for the same few shapes will catch the vast majority of real-world vulnerabilities, and it's so much more efficient. So I'll just leave you with this question. As you go back to your work, think about the patterns we just discussed. Does your application rely on IDs in the URL? Does it have one of those preview features? Does it have a critical multi-step process? What's the one pattern that, deep down, you suspect might be hiding in your code right now? Go find it.